Welcome to our cosmic journey through the solar system. Today, we're venturing to the innermost planet, a world of scorching heat and freezing cold. A place of mystery and wonder, Mercury, often overshadowed by its larger, more dramatic neighbors. Mercury holds secrets that challenge our understanding of planetary formation and survival. It's the smallest planet in our solar system, not much larger than our own moon, yet it orbits the Sun faster than any other planet, completing a year in just 88 Earth days. But don't let its speed fool you. A single day on Mercury is an incredibly long and strange affair. So buckle up as we explore the extreme environment, the unique features, and the incredible missions that have dared to visit this enigmatic world right next door to our star. Imagine a world where the sun in the sky is more than 10 times brighter than what we see on Earth. This is the reality on Mercury. Being the closest planet to the sun, its surface is subjected to an unrelenting blast of solar radiation. Daytime temperatures can soar to a staggering 430 degrees Celsius, hot enough to melt lead. You might think this makes Mercury the hottest planet, but that title actually belongs to Venus, thanks to its thick, heat-trapping atmosphere. Mercury, on the other hand, has almost no atmosphere to speak of. It's so thin, scientists call it an exosphere, composed of atoms blasted off the surface by solar, wind, and micrometeoroids. This lack of a protective blanket means there's nothing to hold in the heat. So, when night falls on Mercury, the temperature plummets to a bone-chilling minus 180 degrees Celsius. This creates one of the most extreme temperature swings in the entire solar system. A difference of over 600 degrees Celsius between day and night. One of Mercury's most peculiar features is its day-night cycle. We mentioned a year on Mercury is only 88 Earth days, but what about a day? This is where things get really weird. Mercury is tidally locked to the Sun in a 3-to-2 spin-orbit resonance. What does that mean? It means that for every 3 times it rotates on its axis, it orbits the Sun twice. This complex dance results in a single solar day on Mercury, the time from one sunrise to the next lasting a whopping 176 Earth days. That's 2 full Mercurian years. So, if you were standing on the surface, you would experience a sunrise, then an incredibly long day lasting 88 Earth days, followed by an equally long night. This slow rotation and rapid orbit also create a bizarre celestial phenomenon. At certain points on the surface, an observer could watch the sun rise, then appear to reverse course and set, before rising again. This is known as a retrograde sunrise, a truly alien spectacle, unique to Mercury. For centuries, Mercury remained a faint, elusive point of light in our sky. Difficult to observe due to its proximity to the Sun. Ancient astronomers knew of its existence, but its true nature was a complete mystery. The first spacecraft to shed light on this world was NASA's Mariner 10, which flew past Mercury 3 times in 1974 and 1975. Mariner 10 was a trailblazer. It was the first mission to use the gravity of one planet, Venus, to slingshot itself towards another. It mapped about 45% of Mercury's surface, revealing a heavily cratered landscape, eerily similar to our Moon. But Mariner 10 also uncovered a huge surprise. Mercury had a magnetic field. This was completely unexpected for such a small, slowly rotating planet. Scientists had assumed its core would have long since cooled and solidified. The presence of a magnetic field suggested that Mercury must have a liquid outer core, just like Earth. This discovery completely rewrote the textbook on small, rocky planets. After Mariner 10, Mercury was left unexplored for over 3 decades. The challenges of getting a spacecraft into a stable orbit around the planet are immense. The Sun's powerful gravity makes it incredibly difficult to slow down a probe enough to be captured by Mercury's much weaker gravitational pull. But in 2004, NASA launched the MESSENGER spacecraft, which stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. After a complex journey involving 6 gravity assists from Earth, Venus, and Mercury itself, MESSENGER finally entered orbit around the planet in 2011, becoming the first and, so far, only spacecraft to do so. For 4 years, MESSENGER orbited Mercury, mapping its entire surface in high resolution and gathering unprecedented data. Its mission was to answer the key questions left behind by Mariner 10. Why is Mercury so dense? What is the origin of its magnetic field? And what are the mysterious bright deposits in its polar craters? One of MESSENGER's greatest discoveries confirmed a long-held suspicion. In the permanently shadowed craters near Mercury's poles, where sunlight never reaches, the spacecraft found definitive evidence of water ice. This might sound impossible on a planet where daytime temperatures can melt lead, but these deep polar craters are some of the coldest places in the solar system. The ice is thought to have been delivered by comets and asteroids over billions of years and has remained frozen in the eternal darkness. MESSENGER also revealed that these ice deposits are often covered by a layer of dark organic material, which insulates them and prevents them from sublimating into space. The discovery of water ice and complex organic molecules on the solar system's innermost planet has profound implications for the delivery of the building blocks of life to the early inner planets, including our own Earth. Another puzzle MESSENGER helped solve is Mercury's incredible density. For its size, Mercury is the second densest planet in the solar system after Earth. This suggests it has a massive metallic core that makes up an astonishing 85% of the planet's radius. For comparison, Earth's core is only about 55% of its radius. Why is Mercury's core so disproportionately large? The leading theory is that in the early, violent history of the solar system, a giant impact stripped away much of Mercury's original crust and mantle, leaving behind the dense iron-rich core. MESSENGER's data supported this idea by analyzing the chemical composition of the surface. it found surprisingly high levels of volatile elements like sulfur and potassium, which should have been vaporized by such a catastrophic impact. This finding has sent planetary scientists back to the drawing board, forcing them to refine their models of how Mercury, and indeed all the rocky planets formed and evolved. The story is more complex than a simple giant impact. The exploration of Mercury is far from over. A new chapter has already begun with the Bepi-Colombo mission, a joint project between the European Space Agency and the Japan Aerospace Exploration Agency, launched in 2018. Bepi-Colombo is actually two orbiters traveling together: the Mercury Planetary Orbiter and the Mercury Magnetospheric Orbiter. This dual spacecraft approach will allow for simultaneous detailed study of the planet and its magnetic environment, after its own long and winding journey through the inner solar system. Bepi-Colombo is set to arrive at Mercury in late 2025. It will build on the legacy of Mariner 10 and Messenger, aiming to answer the lingering questions about Mercury's origin, its lopsided magnetic field, and the nature of its icy poles. With its advanced suite of instruments, Bepi-Colombo promises to give us our most detailed look yet at this fascinating world of extremes. Mercury serves as a powerful reminder of the diversity and wonder hidden within our own solar system. It's a planet of fire and ice, a world with a gigantic iron heart and a bizarre slow-motion day. Its heavily cratered surface tells a story of a violent past, while its frozen poles may hold clues to the origin of water and life in our cosmic neighborhood. From the pioneering flybys of Mariner 10 to the groundbreaking discoveries of Messenger, and with the promise of Bepi-Colombo on the horizon, our understanding of this small, swift planet continues to grow. Mercury is not just a barren rock close to the Sun. It's a dynamic and complex world that challenges our assumptions and fuels our curiosity. It teaches us that even the most extreme environments can hold incredible secrets just waiting to be uncovered. Thank you for joining us on this exploration of Mercury. There's a whole universe of stories out there, and we're just getting started. If you enjoyed this journey to the heart of the inner solar system, don't forget to like this video, subscribe to the channel, and hit the notification bell so you won't miss our next cosmic adventure. What planet should we visit next? Let us know in the comments below. Until next time, keep looking up.